Done. Not one participant can come change that the YouTube. Shall I? Ah, ah. Shall I click? Yeah. Good morning, students. Welcome back to Botany first year class. So till now we have finished the LAQs part in the Hello, welcome back to Botany first year class students. We have already seen the LAQs from two different chapters. Those are the morphology and the flowering plants, that is the root modifications, stem modifications, and the racemose inflorescence we did. And the next one is the 7th chapter, sexual reproduction in flowering plants. That is the embryo sac structure, wall layers of microsporangium, and the process of fertilization. Then the casmogamous flowers, that is the pollination in the casmogamous flowers. So all these 7 LAQs we have seen till now. If you prepare with these 7 LAQs, you can easily go with the 2. And the last one LAQ is there in the 7th chapter. We will discuss about that the last. Okay. So first of all, prepare with this. Now we will start the SAQs from the easiest chapter. Okay. So in this, what we have to see, that is what we are going to see in the SAQs, that is from the last of the reader, those chapters will start. That is the 13th chapter, ecology, ecosystem. Ecology. We will start with this chapter SAQs, because from this 6 SAQs, 1 SAQ is mandatory for the SAQs. That is the 8 SAQs. 1 SAQ has to come from this chapter and 1 VSAQ. That is 1 4 marks question and 1 2 marks question is mandatory. 2 marks is 1 question. This is the mandatory one from this chapter. That is a total 6 marks weightage is there. So where we can score very easily, this is 6 marks. There is the first one is the what we have read for the 5th chapter. 1 LAQ was over from the chapter 5. And what we learned till now, the 7th chapter, at least 1 LAQ, if not this also. Okay. That means here 16 marks. In that, if we have not written or anything, 14 marks we can get. And 14 plus here 6 marks as it is, we need to get. That is 20 marks we got right now with the 3 chapters what we learned. So it's the very easiest one for us. So better to learn the chapters which are having a good scoring capacity for the SAQs, LAQs, and the VSAQs. Obviously, we need to learn from all chapters. Okay, so the first one in this chapter, the first SAQ is the types of hydrophytes. Types of hydrophytes. So this is the one what we got in the March paper. Again, we may get this question or else some other question. So in this, basically important 7 SAQs are there from this chapter, but don't bother with the number 7. But here we will get the 1 question mandatory and all the questions are linked. Okay, so the types of hydrophytes. So here what they will ask, what are hydrophytes, and list out the different types of hydrophytes in detail. So that is the 4 marks question. So here you have to write the definition for the hydrophytes, then types of hydrophytes is mandatory. So the first one is the definition of hydrophytes. What is meant by hydrophytic plants? The plants which are living in the abundant water medium or else in the waterlogged areas, whatever may be, that is the abundant water medium. So this word should be there in the definition. When the plants which are living in abundant water medium are called as the hydrophytes. Abundant water medium. So those are the hydrophytic plants. And how many types of hydrophytes are there? Total 5 types of hydrophytes. Here the sequential order is very important again. The first one is the free-floating hydrophytes. And the second one is rooted hydrophytes. with floating leaves. This is the second one. Now comes the third one. Submerged, suspended hydrophytes. Submerged suspended hydrophytes. And the fourth one is submerged rooted hydrophytes. Submerged rooted hydrophytes. And the last one, that is the fifth type of hydrophyte, is the amphibious plants. These are the 5 different types of hydrophytes. So in this, in the reader or in your materials, they have given as the submerged hydrophytes. Again, the submerged hydrophytes, they have given it as the 2 types: submerged suspended, submerged rooted. Sometimes they may shuffle this, but we should not shuffle. This is the streamline what we have to learn. So the first one is the free-floating hydrophytes, which occur on the surface of the water. So the first one is the free-floating hydrophytes. Free-floating hydrophytes means the plants which are not rooted at the bottom of the lake and freely floating on the surface of the water. Those are called as the free-floating hydrophytes. Okay, the plants which are freely floating on the water surface and they does not connected, otherwise rooted at the bottom of the water. Those are called as the free-floating hydrophytes. And in this one, the best example, what we can say is Pistia. So here we have to write only one sentence. The plants which are floating on the water surface does not rooted at the bottom and they does not have any contact with the soil molecules. Example, Pistia. Now we have to draw the diagram. Here only we need to draw the diagram. This is the Pistia, what we have to draw. Okay, no need of labeling, nothing, but the diagram you should draw then and there itself. And now comes the second one. Second one is rooted hydrophyte with floating leaves. That means the plants are completely rooted at the bottom, attached to the soil surface. Rooted hydrophytes with floating leaves. In the side heading only, complete sentence is there what we have to write. The plant is rooted at the bottom of the pond and having the leaves that are floating on the surface of the water. That much only. Same sentence you need to just expand it. That's it. That is the explanation for this. And in this, remember the example. Example is Nymphia, lotus, You can remember the lotus now. So you can write the lotus, otherwise nymphia. Here, especially we have to go with the somewhat English names as well as the scientific names only we have to write. So no option left out. So remember the word as nymphia. So here we have to draw the diagram again. Here itself, we have to draw the diagram. If this is the water surface, wait. If this is the water surface, then we have to draw the petiole and the leaf on this surface. Now we have to draw the flower. Like this. So this is the, and here you have to draw the, fill up with the water. And rooted system, no need for us to draw. But the leaf and the flower we have to draw, and the water. So this is the complete second topic in the second type in the hydrophytic plant. That is the rooted hydrophyte with the floating leaves. Now comes the third one. That is the submerged suspended. Submerged suspended. So in the submerged suspended hydrophyte, what is meant by suspended? That is, they are present freely in the water, but not attached to the soil, and they won't come out of the water. On the water surface also they cannot survive. Otherwise, at the bottom of the pond also they cannot survive. That is freely present in the water only, in between the water layers. That is the suspended, submerged suspended hydrophytes. So in this, the best example is hydrilla. Hydrilla. So here we have to draw the plant. The stem is branch and we can see the leaves arranged like this. Okay, so this is the hydrilla plant. This is the hydrilla plant, and this is completely present in the water. This is the submerged suspended hydrophyte, what we will say. Okay, and now comes the fourth one, that is the submerged rooted hydrophyte. Submerged rooted hydrophyte. Submerged rooted hydrophyte. So in this, the word only, side heading only, we can say the plant is fixed at the bottom of the lake or pond and having the root system, and it is present inside the water. That is the submerged rooted hydrophytes. Example, Vallisneria. So how the plant looks. This is the bottom. Now the Vallisneria plant is having a ribbon shaped leaves, long ribbon shaped leaves are present and having the adventitious roots at the bottom. Root system is adventitious. Like this. This is the bottom of the lake. This is the Vallisneria, and it is completely present inside the water. That is in the water only. That is the submerged rooted hydrophyte. Always we need to draw the water. If we are not drawing the water, it's the wrong representation for the plant itself. Okay. And the last one is the amphibious plants. Amphibious plants, the best example is Sagittaria. Okay, so what is meant by amphibious nature? The plant which can live both in the water and on the soil. Those are called as, that is called as the amphibious nature. Amphibious plants. Amphibious plants means the plants which can survive in the water as well as in the outside the water, that is on the soil also. The plants which can survive, those are called as the amphibious plants. Example, Sagittaria. So in this, how the plant looks. The plant is present inside the water a little bit and outside the water a little bit, so that the leaves which are present on the surface of the water are somewhat bigger in nature. And the roots and the leaves which are present below the water are highly dissected. Like this. This is the how the plant lives. Without the water also it can survive. But 1/4 of the plant is under the water and 3/4 will be above the water surface. That is the hydrophytic plant. That is the amphibious hydrophytes. So in this, the best example is the Sagittaria. Okay. So with this, we have finished the one question from this chapter, that is types of hydrophytes. Now comes with the second question, that is the anatomical adaptations of hydrophytes. What is meant by anatomical adaptations? Anatomical adaptations of hydrophytes. So here anatomical means how the plants arranged themselves from the inside to sustained in the waterlogged media. That is the anatomy, the internal arrangement of tissues of a plant. That is called as the anatomy. So anatomical adaptations, they are making themselves to adjust to this waterlogged situation, that is in the presence in the water itself. So those are the anatomical adaptations. That means here you should not write how the plant looks externally. Internal arrangement of the tissues and the xylem, phloem, and the root and the stem, how the leaves in the inside the leaf tissues, that only we need to mention, not the external characters. Remember, if you are giving the heading and writing about the external characters of the hydrophytic plants, then you won't get a single mark. But at least if you have written any such word that is the internal anatomy related, then half mark they will give, not more than that. So you are losing complete marks if you are not writing the correct answer and you feel that I have written the correct answer, because you know the answer and the heading you don't know. For some other question, you are writing some other answer not related to the question. Remember, anatomical adaptations means internal arrangement of the tissues of the plants which are meant to go with the hydrophytic nature. So here first comes, if you divide this into the 3 different parts in the plant body. So what are the 3 different parts in the plant? Root, stem, and the leaves. Isn't it? What we know, based on that, if you remember, then it will be the good one to write about the anatomical adaptations. So what happens in the root cells and in the stem and in the leaf cells? Together, if you are having an idea, then you can write it very easily. So the root system, for every plant, root is must to fix the plant to the soil molecules and to absorb the moisture, that means the water from the soil. This is the nature of the root system now. But in the hydrophytes, have you seen the type of fixing the plant to the soil? No. In the types of hydrophytes only we have seen some plants are freely floating on the water surface, and some plants are just present without the roots, submerged, suspended. So we need to write like that. Okay, root system is absent, completely absent in some plants. That is the hydrilla. Okay, once the root system is in the free floating, that is the pistia, where the root system is the adventitious root system meant to float on the water surface. So these are the balancing roots. Okay. And what is there inside these roots? The cells are completely filled with air. So that is called as the parenchyma. Parenchymatous tissue is present. What we have to write? Parenchymatous tissue is present in the roots of some plants to float on the surface of the water. Example, pistia. What we read in the types, based on that only I am saying the points for you, so that it's easy for you to remember and go with the exact words and the exact points. Okay. And the next one is in some plants root system is absent and we don't bother for this. And the next one is the root caps. Okay. Root caps are also comes in the morphological adaptations. Now we no need for us to write anything. Now comes the stem. Stem is also having this air in them, which helps in buoyancy. Okay, which helps in buoyancy. Buoyancy means freely floating on the water surface. That is called as the buoyancy. So here, the parenchymatous tissue is filled in the cortex of the stem. In the cortex of the stem, and it will be helpful in the buoyancy of the plant body. Okay, and next comes the after that the leaves. The leaves, the internal arrangement we have to write over here. The leaves and the petiole of the leaves. The leaf petiole is having the erenchymatous tissue more. It is more in the petiole of nymphia. This we have to write over here. Why? Because if the nymphia, petiole means stalk of the leaf, that will be always having the characteristic features of the stem and the leaf. But here, mostly we will see the stem characters in the petiole of the nymphia. So we have to write about those characters only here. The petiole is having the erenchymatous tissue and it is having the mechanical tissues in it, which gives the rigidness for the petiole to make the leaf to float on the water surface. So here it is having the erenchyma and the mechanical tissues. Okay, but in all other hydrophytes, mechanical tissues are completely absent, except in nymphia petiole. In all other hydrophytes, mechanical tissues are completely absent. What we have to write the second point. Okay, so the first point is erenchymatous tissue is very well developed. Erenchymatous tissue is well developed. That is the first point. Second point is mechanical tissues are completely absent. Are completely absent. But in some plants, they are present. Mechanical tissues are completely absent. So in this, which example we can give? Examples we need to give over here. Example is Pistia. Okay. And in some plants, in nymphia. So we have to write with the example only. In nymphia, mechanical tissues are present in the petiole. That's the one what we have to write. And the next one is in the stellar region. In the stellar region, which types of tissues are present? There is the xylem and the phloem has to be present now. But here, xylem shows a cavity-like structure. In the stellar region, xylem shows cavity. This is the most important.